Bonding involve sharing or transfer of electron to attain an octet or duplex state. To attain an octet or duplex state. So we'll start with electrovalence. Electrovalent bonding. Electrovalent bonding is the transfer of electron from metal to non-metal. What did I mean? Metal has to lose. Metal will lose electron. Non-metal, they gain the electron. They gain electron. So we'll talk about metals from group 1, group 2, group 3. They are metals. Then non-metals, we'll take group 6 and group 7. So let's take for example sodium chloride. Sodium chloride. Sodium chloride. Sodium is 11, and if you want to arrange it according to KLL shell, remember K is always 2, L is 8, and M is 18. Before you get to 18, you add up. It means this is 2 plus 8, and that is going to give us what? 10. The rest for this one is 8. I hope we are getting using the formula 2n squared. Our n equals to 1. You start from 1 for this side. This is n, the number of share 1, the number of share here 2, the number of share here 3. So this will make up 18 electron. But if you want to add 2 plus 8, 10. So the next one will be 8. The next one, n equals to 4. Then your capital M is 32. By the time you add up 2 plus 10 plus 8, 18. Subtract it from 32. What do you have? You have 14. 32 minus 18. Subtract. What do you have? We have 14. So the next share here must contain 14 electrons. Must contain 14 electrons. So looking at this, looking at sodium first. Sodium is Na, and that is 281. 281. 281. So Cl is 287. So what happened? This needs 1 to attain a what? An octet state. An octet state, because for them to be stable, they have to attain an octet or a duplex state. An octet or a duplex state. An octet or a duplex state. So this one will lose 1 electron. It will lose 1 electron. So it will lose 1 electron. It will lose 1 electron to 7. So when it loses, it becomes Na plus. It means it has lost 1. So this one loses 1 electron. Then this Cl gain. So whenever it gains, it becomes negative. When an atom gains electron, it becomes negatively charged. It negatively charged. And when an atom loses an electron, it becomes negatively charged. And when an electron negatively charged, and when an atom loses electron, when an atom loses electron, it becomes positively charged. It becomes positively charged. So, what does that mean? You will end up having Na plus Cl minus. So this has attained an outer state. This also has attained an outer state. So this is what we call electrovalence. I want us to take another example. When we have something like 2 Na2O. So Na is what? 11, which is 281. Oxygen is 2826. Sorry, this is 8, atomic number 8. Then your sodium is 11, which is 281. This needs how many? 2 electrons. That is what we mean by electrovalence. They have to do what? Give. They will give. So this sodium is going to lose an electron. The other sodium also is going to lose an electron. While this is going to gain, while this O is going to gain each electron, making 2. So these end up to become Na plus, because they are 2. They loses electron, 2 electrons to this. So this become 2 8, this become 2 8, and this become 2 8. So in this case, this is electrovalence. Now let's look at covalence. Covalent bonding. Let's look at covalent bonding. Covalent bonding. In covalent bonding, this with sharing. It involves sharing of electron. To attain an octet or duplex state. It involves sharing. You will share electron, and basically it is non-metal. Non-metals. How? Let's start with hydrogen. Hydrogen has just 1 electron. So the other hydrogen also have 1 electron. So 2 of them will do what? They will share. They will do what? They will share. This is hydrogen. We can have Cl2. Cl is 287. This one is a duplex state. This is 2. In this case, you will look at this. This makes 1. This makes 1. If you look at that. So the 1 that they make is what they will share. This will become 6. This will become 6. You will remove 1 from here. This is 1. This is 1. So when you are drawing, this is a third shell that I'm drawing. You will put 1 2 1 2 1 2. Then it joins with this 1 2 1, 2, 1, 2. Then this is 1, 2. This is a 1, 1. The one here and the one here. That's what they are sharing. That is what they are sharing. So that is when you will end up having something like this is covalent bonding. This is covalent bonding. I want us to look at another example like CO2. 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 If you look at CO2, C is 6 and that is 2, 4. O is 8, which is 2, 6. Then the other O2 is 2, 6. So in this case, you will think this needs to, this needs to. This needs what? 2. This needs 2. So when you are doing that, you will think this is 4 already. This is 4. So you break this one down. This is how it is. Can you see? The 2 and the 2. You will see how it's going to work now. So we will look at this. This is carbon. We have 4. So you will put the 2 here. You will also put the 2 here. So here is O, oxygen. That means what? 1, 2. 1, 2. 1, 2. It is balanced for this. This is a 4. 1, 2, 3, 4. 1, 2. So in this case, you also make this to be 4 and make this also to be 4. Because it needs 2. So when you subtract, so you extend this, you extend it, it becomes 1, 2. I'm going to shade this. When I shade this, you will know it's for what? It's for O. It's for O. Why the 2 is contributing. So the 2 here for this is it. So the same thing, this will appear to have what? The 2. So you have the 4 here. 1, 2, 3, 4. Standing for what? For O. This is a shaded part. So they are sharing electron. This is carbon. So sharing electron between them. So this is covalent. So I'm going to give us an exercise. So classify into electrovalent and covalent bonding. Electrovalent and covalent bonding. So we have 1 HCl, 2 SO2, 3 KCl, 4 Na2 K2O, 5 CH4. So you will classify into electrovalent and covalent bonding using the above, using the